2 homework due tonight, 6-5 and 6-6. Does anyone have any homework questions for me? If you do, you can type in the chat room or ask me. Anyone? Again, do not forget that your test is next, not next week, but next 2 weeks. So 2 weeks from on next 2 weeks. So it will be again, it might be changed a little bit, maybe not A to M. I will look at your list again because it looks like A to M looks like a lot more people than N to Z. So I might change a little bit. I will look at your list and I will announce it to you tomorrow, next week. So next Monday, you will get a review of your first test, and then your first test will be the following Monday. So so depends on your last name. If your last name right now is still A to M, so if your last name is A to M, you attend your first test on Monday. Otherwise, N to Z, you attend the test. You come to the class room. I think it's CLA 116. It's in your syllabus, so make sure you guys check the syllabus for your tests. And if you cannot make in either one of those days, you want to go to an earlier one or later on, please email me as soon as you can, because I only have allowed like 15 to 20 around 20 students in the classroom due to COVID-19 procedure. So make sure you guys email me with that. And make sure you wear a mask when you're going to the college. That is the next thing I will point out to you. Anyone have any questions for me so far with your homework or your coming up test 1? Before we continue with chapter 7.1 and start 7.2. If you do, you may stay back after class if you want to. And again, I think I sent you guys about the Math Resource Center. That is a tutor instructor called Brian. So if you want to, I really, really highly recommend you to sign up for him. At least 2 hours or 1 hour for 2 days in a week. Okay, so if we can sign up, with him. We're gonna continue with number 6 here. So last time we did number 1 till 2, 3, 4, 5 using what we call as a trigonometric identity in this case. So in what we're gonna do next here in question 6 and 7 here is question 6 and 7, you required to perform some indicator operation. Indicator operation means that if you have square, you have to FOIL it. If you have addition, if you have a fraction, if you have addition and subtraction, you have to find the LCD. Okay, so go ahead and question 6. You guys help me to FOIL this. Hopefully you guys know how to FOIL this. So sine x plus cosine x squared. Go ahead and we're going to do question 6 here. Go ahead and FOIL it out. And I will ask you guys for the answer. So again, when it's squaring, it's the same as multiply by itself twice. So this will be the same thing as sine x plus cosine x. So make sure you guys know how to, you should know how to FOIL. Yep, FOIL question 6. Damon, Damon, can you tell me what you have when you FOIL this out? Damon?
It's sine x squared, or sine, I think, because it's sine times sine, so it should be.
Sine what? Yep, sine times sine is.
Sometimes is it sine squared or
Mm-hmm.
yeah, sine squared x
Mhm.
plus cosine sine.
This is sine squared x. Uh-huh. I did this. What is sine x times cosine x? Just sine x times cosine x. What else you have?
And then also cosine x times sine x, and then cosine squared x.
Now, when you multiply cosine x times sine x, you still get what?
Sine x, cosine x, cos.
So that means you got how many of sine x, cosine x here?
2.
2. Yep. And what is the last one you say?
Cosine squared x.
Yep. Very good. So this is your foiling. So it's like normal foiling that you guys have. Now, we need to use identity. So can someone tell me, by looking at this foiling, which identity can be applied here? Anyone?
Would it be Pythagorean identities?
Which one? The first one, the second one, the third one? Danny.
The first one.
The first one. So in this case, you can take the sine square x plus the cosine square x using the Pythagorean identity. So what you get when you combine, when you use the identity for these two red ones, that will give you what?
1.
1. And what we left here, the plus 2 sine x cosine x, that will be your remaining part of it. So this is your answer in this case. Okay. So so this is your answer for question 6. So make sure you guys know how to FOIL. And then usually when you FOIL, you got the square, and usually once you come to square, then we use the Pythagorean identity to reduce that to 1. Usually 1 or -1 depends on your identity here. Okay. Right, so this is how we do question 6 on your on 7.1 homework, 7.1 notes. Question 7. This is where you add and subtract fractions. So every time when you add and subtract fractions, you have to find the LCD because your denominator is different. If your denominator is the same, then you like adding and subtracting fractions, then you do the find LCD. Can someone tell me what is the LCD for question 7? Oh, if I want to make this a bit easier, I just say 1 over x plus 1 minus 1 over x minus 1. Okay, I just dropped the secant. I just put them x. Can someone tell me what is your LCD for this case? If you know how to find an LCD, then you should know how to find LCD for that case. Anyone know how to find an LCD here? You guys know what LCD means, right? Least common denominator. Ming? Know your LCD here, Ming? Or anyone? Anyone knows the LCD for this one? Not plus 1. Anyone?
Would it be x squared minus 1?
Yep, or we can just put it in not foiling it. It's just x plus 1 and x minus 1. Usually we just leave it like that, so we do have to foil out. So your LCD in this case are these two combined together. And do you guys remember how you, because once you find your LCD, you need to multiply this so that it will get the same denominator. So what we need to multiply on the first one is x minus 1, because that is what is missing here. And in fraction, if you multiply this with x minus 1, you have to multiply the top one also by x minus 1. Can someone tell me what is missing on the second fraction? If if you compare to your LCD.
X plus 1.
Very good, Anders. That is correct, x plus 1. So you need to multiply the top one by x plus 1. The reason why we're doing this is because that now your denominator is the same, because you have the same denominator, which is x plus 1 and x minus 1, which is also the same as your LCD. So once we got the same denominator, then we can combine, like we can do some the numerator, we can do some combined like terms and distributing. So what we have on top in this case is x minus 1 on the first case. Now this is very tricky because the negative one, the one here will belong to this the one here. So actually when you distribute the second fraction, you don't get a 1, you get negative, you have to distribute a negative 1 in there. So when you distribute a negative 1, you get a negative x minus 1. So this is one of, make sure you guys know that this, when you distribute, not 1, but negative 1. And you find out that, that when you combine like terms, you will find out your x in this case cancel. What you get in this case is negative 2 over by x plus 1 and x minus 1. So this is your how we simplify this kind of what we call as rational expression. So this is very similar to number 7 here. So can someone tell me now what is your LCD in this case? Anyone? Ming, you want to do it one more time since you get it wrong? Anyone? Start saving things. Anyone?
Would it be secant squared x minus 1?
Again, we keep it as, I really suggest you guys to keep it as the parentheses, which is correct, Anders. So secant x plus 1 and secant x minus 1, which is correct. When you FOIL this, you will get secant square. When you FOIL this, you should get secant square x minus 1. Yep, that is correct. Okay, so when you FOIL this, secant square x minus 1. So what is missing here that you need to multiply to your, so that it will be the same as your LCD? What term is missing here for the first fraction? So this is missing
secant x minus 1.
So you have to multiply that on the top. What is missing on this fellow? The second one. Secant x plus 1, right? And your else, so what you do here now is your denominator is the same like what we did last time here. So yep. So it will be secant x minus plus 1. Doesn't matter which one comes first. So secant x plus 1 and secant x minus 1. So what we have on the numerator, anyone? So this will get secant x minus 1. And what do I tell you about this 1 here when you distribute? You're not distributing 1, you're distributing what? Negative 1, right? So this will give me what when you distribute? It's very similar to what you get here. You get a negative secant x minus 1. And what do you notice when you do this is your secant x on the top will be canceled. So what you left in this case is negative 2 of this fellow. Now we can FOIL this out. Usually we just leave it like this, right? Negative 2 over by secant x plus 1 and secant x minus, very similar to what you did in the one that I show you down here. But now we're going to FOIL this out, because the reason why we have to FOIL this out, which you will get secant square x minus 1, is because we can use identity to it. So can someone tell me what identity can be used for this secant square x minus 1? Okay. Try to move things around here so you guys can see it. Anyone know an identity that we can use for secant square x minus 1? Is that reciprocal, quotient, Pythagorean, cofunction, or even up identity?
Isn't it Pythagorean?
Which one? The first one, the second one, or the last one?
The second one?
Second one. But the second one doesn't have secant square x minus 1. It has 1 plus tangent square x equals. So can someone tell me how you write secant square x minus 1 in the using the second one? Anyone? Second one is correct.
Subtract 1 from both sides.
So what you subtract 1 on this side, so you get what? Secant square x minus 1, right? So can someone tell me what is secant square x minus 1 is?
Tangent squared x.
Tangent square x. Now, because this tangent square x is, so using Pythagorean, right? Using pi. So pi stands for Pythagorean identity. And then we can use one more identity here, is because if you want to rewrite this, this is the same thing as -2 times 1 over tangent square x. Can you name me another identity that can be changed, this 1 over tangent square x? This, anyone? Which identity is 1 over tangent square x? Reciprocal, quotient, Pythagorean, even, cofunction? Which one? One over. So what is here has 1 over on it. It's very obvious.
Reciprocals?
Reciprocal. So what is 1 over tangent square x? It will be what?
Cotangent?
So this is -2 cotangent square x. So this is your answer for question 7. Yep, this is, I say this is tough. So again, in my test, I won't call you to do this type. What I want you to do is, I want you to prove the identity that 1 over secant x plus 1 minus 1 over secant x minus 1 equals to -2 cotangent square x. So this is what you will get in my test for this coming up test, which you will learn in 7.2. So 7.1 and 7.2 are very similar. The only thing is 7.1, when you do your homework, it is straightforward type like this, means you have to work it out and show me the work. But when you look at 7.2, it's all going to be proving identity. That means the answer is on the right side. So the one that I showed to you is very similar to, it's not in here. Maybe similar to question 5, because they have fractions. So anything that have fractions that you add and subtract, like number 3, is also very similar to what you did over on here that we did. So everything that you have a fraction, that you have addition on it or subtraction on it, you are required to use number 7 here. So it's very, very, very important. So that's why I'm showing you some steps. So when you do 7.1, they're doing exactly 7.2 work. Okay. So then we're going to continue with number 8 here. If you read question 8, they want you to factor this trigonometric expression. So hopefully you guys are good in factoring. So can someone look at question number 8? What can we factor here? Anyone? Anyone know what to factor out? What can we factor out here? What in common? This is why I'm teaching you how to think outside the box. So I'm not doing a lot of work today. You guys have to do some work for me today.
Sine square.
Very good. Sine square x It's
Yeah.
cut out, very good. So what happens when you factor sine square x out when you left?
So secant squared x.
And what?
Mm.
Hmm?
Oh,
Because you multiply this, you only get him, but you still have the back. So
and the
minus
sine square x. Yeah.
minus what?
Minus sine square x.
No, if you minus sine square x, then this will be, if you distribute, it'll be sine 4x.
Plus. We have to do plus.
No, this is just taking 1. Okay, so when you take sine square out from sine square x, you get 1. So when you distribute, you will get the sine square x here. So once you factor, we should use the identity. Do we use this? Do we know this identity already? Which is using what? We just did it just now, right? Which
It's
identity?
Pythagorean.
Pythagorean. And can someone tell me what is secant square x minus 1 is?
Tangent squared x.
Tangent square x, very good. We just did it, right? On number 7. However, this last time, remember, we used a reciprocal. The reason why is because the tangent square x in the denominator. So we put 1 over it. This one is not in the denominator, so do not use the reciprocal. So can someone tell me what can we do in here? So tangent square x can be changed into what? That is correspond to sine. So we can use quotient identity, but unfortunately, quotient identity, the sign is not in the denominator. So we just leave your answer like this. The reason why we do not want to use quotient identity here is because your sign is not in the denominator. There's no cancellation. So if you want to use your quotient identity for here, you can. Unfortunately, that's what I mean by you cannot canceling, because tangent in this case is sine over cosine. Unfortunately, you cannot, there's no cancellation between these two. So you can also write this down, you can make it over 1. You multiply them straight across. So this is actually sine 4x. Because sine squared times sine squared is sine 4x over by cosine 2x. So there is also another way for us to write this answer, which is this one. So so that's the reason why when you look at your homework here or your question here, it says there is more than one correct answer. That means that your answer can be this one and your answer can be this one. But in my test, I will call you to prove. If my proving is up to this, then you have to continue using the quotient identity. But if my proving is only up to the orange one, then you just need to use the Pythagorean identity. So that's the reason why that when you guys do my test, I will tell you where you stop. Either you stop on the orange one or you stop on the brown one. Okay. So so make sure you guys know which one to do. Yang, this is my last message. Yang, are you there? Yang, are you there? Are you there, Yang? I'm gonna tell you, Yang, I am not taking attendance the last time you are not here, so I will mark you for absent. So I am gonna be asking you to wait till I'm asked for attendance. So for the future, if you are just type present and just leave my class, I will make you absent in the classroom. So this is very serious, Yang. So this is my last time to you here is, do you got what I'm telling you here, Yang? You're not just come here, say present, and then leave the classroom. I'm not the intake attendance yet. So you better reply back to me now. Didn't reply back. You know what, Yang? I will just withdraw you from my class. Very easy. So, yep, I can do that. Yep, you just cross the line. So the next one in this case is number 9. We also need to factor. So can someone tell me which one of this can be factored? This is question 9 in your homework here, in your notes here. So can someone tell me which one can we factor cosine x minus 2? Can we factor that follow-up? No, we cannot factor him, so that's why it will remain as cosine x minus 2. So can we factor cosine square x minus 4? So if you look at this, this is very similar to x squared minus 4. So anyone know how to factor this one? You better know how to factor him. So Yang, what is a factor of x squared minus 4? Yes, oh. I'm worried about your first test, because your first test will show me how well you do in my class. You're paying attention or not, and all those things. Anyone know what's a factor for x squared minus 4 is? Yang,
X
you
plus
there?
1.
I'm
Oh,
sorry.
x plus 2, and then x minus 2.
Yep. So what is the factor for cosine square x minus 4? It's very similar to what you have here. So in this case, Danny, what's the factor for this one?
Would it be cosine x plus 2, and then cosine x minus 2?
Yep. And what can we cancel here?
The cosine?
Minus 2, right?
Yeah.
So what is your answer in this case is 1 over cosine x plus 2. So this is your answer in this case, and we cannot do anything with this. It's because there's no squaring. So usually when you have square, we will use Pythagorean. And if it's tangent or cotangent, usually we use the quotient identity. And a lot of students thinking about, oh, you know what? 1 over cosine. 1 over cosine is secant. So this is secant x plus 2. And this is actually wrong. Okay. The reason why is because of secant x plus half. This is also wrong. And the reason why you cannot break it down to 1 over cosine plus 1/2, you cannot do this is because this is together. So this is all together. So you cannot break it out like this. So this will be, so you cannot do what I'm just did here. So this will be your final answer in this case. Okay. 1 over cosine x plus 2 in this case. Next, we're going to talk about here is number 10. So question 10 is asking us to factor this follow-up. Cotangent 3x plus cotangent square x plus cotangent x plus 1. So does anyone here know how to factor 4 terms? Factoring 4 terms.
We can divide it into 2 parts.
Yep, we call it groupings. Very good. So you divide this into 2. So what are the common factor? GCF, greatest common factor for the first 2. What can we factor out here? Scudder?
Is that 3? Like, you know,
No,
is that 3
we
or
always take
5?
we always take the smallest power.
Yeah, is that 3 or 5? Just
That's
the
3.
3, okay. So
This is 3.
cotangent square, so cotangent square.
Yep, so you can factor out cotangent square x. And what you get when you factor the cotangent square x? From 3, take out 2, you get how many?
Cotangent cube.
You just get cotangent x And again, when you take cotangent square x from cotangent square x, you get plus what?
1.
Plus 1. So this is how you factor that first one. What can you factor on those two? Cotangent x plus 1. What can we factor here? So that is nothing in common here. So we still can factor, it will be plus 1. So this is still going to be the same as cotangent x plus 1. So you still can factor it, but it's only 1. Every time when you do what we call as factoring by grouping here, you will notice that this parenthesis is exactly the same. So this can be factored as a common factor, and that factor is cotangent x plus 1. A lot of students think because they are the same, so they put a square on it. That is wrong. This is a common factor, so that means you can just factor out cotangent x plus 1. The leftovers, the green one that I have, will be put in the other parenthesis. So you will get cotangent square x plus 1 in this case. So this is the factor for question 10. However, because of there is a square involved, so we're gonna use the Pythagorean identity in this case. So which Pythagorean identity that we have here that will be used for cotangent square x here?
Pythagoras.
Is that the first one, the second one, or the third one?
Third one.
So the third one, so this is actually using Pythagorean identity. So the third one, you do not need to change anything because this is 1 plus cotangent square x. So in this case, what is cotangent square x plus 1? Anyone? That is the cosecant x. And what we have on the first one, which is the cotangent x plus 1 here, will remains as the same. Because we do not want to change this, we cannot use Pythagorean because there's no square involved. So usually this is your answer in this case. The reason why this is your answer is because the question wants us to perform. If you read the question, they want us to factor, which we did, we factor it. And then the question wants us to use identity, which also we did, we use identity. So try your best not to multiplying back. I mean, you can, it will make your answer a bit bigger, but I still accept it. But this is usually what I want you to stop. Okay, so this is how we do question 10, where you have to require to factor it and then use your identity. Okay, anyone have any questions for me?
So why did the cotangent plus 1? Why do we only have one of that instead of 2?
Because this is a common factor. So for example, is when you have like 6x plus 4x, if you factor this x, you factor out, right?
Yeah.
Why don't we put x squared here? But when you factor, you don't put x squared, right? You just put what?
6 plus 4.
Yeah, I mean x, right? Because this is only one, right? So you only factor. So this is a common factor. So when you factor this out, you only have 1. So that's why when you, this same thing like what I did on the purple one. So they're all power 1. So when you factor this, you still only have power 1 left.
Okay, thank you.
So you don't do power 2. So this is one of the rules in this case. Okay, so make sure you guys know this. So once you pick 2 here, then it's ultimately wrong. Okay. Next is question 11. Now, if you look carefully on question 11, this is something I put stars on it. Sometimes when I think you guys know what happens when I put stars, right? Anyone know what is the meaning when I put stars on some questions? I put stars means it's going to come up in your test. Especially this is very important, so pay attention. So if you notice on question 8, 9, 10, you find out that they're all the same except for number 8. This is all cosine, this is all cotangent. This one have sine and secant. But this one is different. It has a cotangent and cosecant. So when you guys have two different trigonometric function here, one is cosine or one is secant or something else, you cannot factor it. In order for us to factor it, they all has to be exactly the same trigonometric function here. So what we need to do here is we have to change the one of this to either to cosecant or the cosecant to cotangent. So so in this case, instead of last time we factor first, use the identity. For this case, we use the identity first, then factor. So this is the opposite way. So it's not always, go that way. It can be move around here. So can someone tell me which one should we change using your identity? Should we use the change the cotangent square to a cosecant, or should we change the cosecant to a cotangent? Which identity should we use here?
Cosecant to cotangent.
How do we change cosecant to cotangent? Which identity?
The third Pythagorean theorem.
Pythagorean requires you to have what?
Oh, square.
Square. Do we have square here?
Nope.
Nope. So we cannot do that. Okay. So make sure you guys know that Pythagorean only can be used. So we cannot change the cosecant to cotangent, but we can do what? Change what? Your cotangent to become what? Cosecant. So what identity we use here to change cotangent to cosecant? We will use the Pythagorean identity. So can someone tell me which one, because it's square now, which one of these is we use to for cotangent square x? The first one, the second one, or the third one?
Third.
The third one, but the third one is 1 plus cotangent square equals to cosecant square. I want just cotangent square. So what happens to this one if I just want just this fellow? Move the one over there, right? So can someone tell me what is cotangent square x if you use a Pythagorean identity, the third Pythagorean identity? This is cosecant square x minus 1, right? So this is just for the cotangent square x. What happens to the cosecant x and minus 1 that we have on the back? We just rewrite it because we don't use any identity here, so we don't change it. Okay. Now we combine like terms and make them as your quadratic. So cosecant square x plus cosecant x, and what we have minus 1 gives us what? Minus 2, right? So now we can factor this. The reason why we can factor this fellow is because now they're all in the cosecant x form. Okay. So this, if you think about factoring, it looks like x squared plus x minus 2. So if you just drop your cosecant off, it looks something like this. Can someone factor this for me? You should know how to factor this. This is very easy to factor. Anyone? What's the factor for it? Jakub? Jack? What is what's the factor for here?
X minus 1 and x plus 2.
X minus 1 and x plus 2. That's correct. So what is the factor for this fellow? It's very similar to what you just did here. So secant, cosecant what?
cosecant minus cosecant x minus 1, cosecant x plus 2.
Yep. So this is your answer in this case. Okay. The reason why I put couple stars here is because it's going to be in your tests. In your test, this is going to be in the equation form, which you will learn this in 7.3. So you will see this again in 7.3. So that's the reason why I put this as a star. So make sure you guys know how to do these kind of questions. It is coming up in your test, your first test. All right. Next, so this is the end of the factoring piece. So we're gonna look at some more examples here. What I'm teaching you here is all gonna be used in 7.2 and 7.3. So that's why you need to watch carefully here. Question 12 is asking us one question that is also like to be asked a lot in your, is to rewrite these fractions into not a fraction form. So what happens is that we want you guys to write this in the not a fraction form. What's the meaning when I say not a fraction form? Not a fraction form means that no fraction. Okay, so that means we need to get rid of this fellow. Okay, so how do we do that? So in order for us to write this in the non-fraction form, is you multiply by its conjugate. You guys know what its conjugate means? If I say 2 plus 3i, what is the conjugate of 2 plus 3i? You should know this is very important. Conjugate. Anyone? Take a wild guess. 2 plus 3i was a conjugate here.
2 minus 3i.
Yep, this is the conjugate. Okay, so this is what we do here is multiply by the conjugate is what our main goal. So can someone tell me what is the conjugate of this? Tangent x plus secant x. What's the conjugate? So conjugate means you just change your middle term.
Tan x minus secant, is that?
Is tangent x minus secant. Yep, secant x. That is correct. So just make sure you guys know the conjugate means the middle term. You just change your sign. It's a plus to minus, minus the plus. As you guys know that when you like fraction, right? So if you have 1/3, if you multiply this by 4, you also need to multiply the top one by 4, right? This is the very basic property of fraction. Anything you multiply on the bottom, you have to multiply the same thing on the top. So in this case, so since you multiply this by tangent x minus secant, this one also has to be multiplied by tangent x minus secant x. The reason why we're doing this is because we multiply this by 1. Okay, this is considered as 1. And we know that when you multiply anything by 1, we preserve the value. That means the number is still the same. So that's why we always want to multiply this by 1. So what we have here is the top part we have is 5 tangent x minus 5 secant x. So I just distribute my 5 in there. And so that's why you get the 5 tangent minus 5 secant. What happens to this one when you FOIL it out? Can someone FOIL it out for me here? So what is tangent x plus secant x times tangent x minus secant x? Anyone? FOILing? Go ahead, FOIL this one out. What you guys got? So tan square x, very good. So this is actually is tangent square x. So when you FOIL, because the middle term will cancel out because one is positive, one is negative. So you get tangent square x minus secant square x. But if you look at tangent square x minus secant square x, can we do something with this fellow? Can we do something with him? Can we apply identity here? And if you say, yeah, then we can apply identity, can you tell me which identity we are applying? So you can figure out there are pretty much a lot of identity used here. So which one is the identity we can use on him? Since they're all square, so we will use what? The Pythagorean identity, right? So can someone tell me which one should we use? The second one, right? So it's 1 plus tangent square, I don't have time to write that, equals to secant square. I just short form T and S. But this question wants us tangent square minus secant x. So can someone tell me how you rearrange this Pythagorean so it looks exactly like him? How do we move around? That's good. Yep, that's correct. So question is, how can you arrange this so that you look exactly like him? How do we move it around? As I told you, right, the identities, you can always move things around. As long as you do like a balance equation, you minus something here, make sure you minus on the same thing on that side. So anyone know how to move this or find what is tangent square minus secant square? We move the secant square to that side. So when you move it to that side, what happens? This secant will become minus, right? So we do have the tangent minus secant, but what we're going to do with this one? You had to move it to that side. And what happens when you move it to that side? This will become what? Anyone?
Negative.
-1. So can someone tell me, or Escada, can you tell me what is tangent square x minus secant square x? This is the same thing as -1. And now we're going to apply this -1 to the numerator. So we're just multiplying this by -1. So as you guys know that when you multiply it to the -1, all your sign will change. So you will get a -5 tangent x and a +5 secant x. So to apply this, you just need to change your sign. So I just rewrite this because the positive, I like to write the positive first. So your answer in this case will be 5 secant x minus 5 tangent x. So this is how we do this question here. And you notice that this has no more fraction. Don't forget, the question is asking us to write this fraction question to become not a fraction question, okay, not a fraction form. So in this case, we did it because this is no longer a fraction form. And again, for us to do that, conjugate is what we are doing. Okay, you guys all right here? Tough. Okay. The next thing we have to do is that use a trigonometric substitution to write this algebraic expression as a trigonometric in a function of theta, when a square of 9x squared plus 25, what is that is, given us at 3x equals to 5 tangent theta, and theta in this case is between 0 and pi/2. So I need to put down that. If I write down as theta is between 0 and pi/2, can someone tell me what quadrant is this belongs to? If you write this in degrees, this is between 0 degrees and what degrees? Anyone know pi/2? Yep.
0 to 90.
Yep. And what quadrant is that from 0 to 90 degrees? 1, 2, 3, 4.
First.
Yep, first quadrant. Very good, Escada, that is correct. And you guys remember when you remember the all students take calculus, what happens to the first quadrant? Everything is
Positive.
positive. So that means that when you guys do some work here, we do not need to worry about the absolute value because all your theta, all your value here is always positive. Okay. So what do we do in this case is we have to use substitution. So in order for us to substitute, because this fellow is a 9x squared and this is a 3x. So can someone tell me how we make 3x to become 9x squared? Should we add, subtract, multiply, divide, square root, square, absolute value, you know, all those stuff that you learned? So how do we make 3x to become 9x squared?
3x squared.
We square it. So as you know that if you square on the left side, you have to square it on the other side. So what we have here will be 9x squared is equals to what? 25 tangent square theta. So what we do here is we take the 9x, the 25 tangent square x, and we substitute into your 9x squared on this square root form. So what we have here is the square root. And then the 9x will be replaced by 25 tangent square theta. And don't forget the 20 plus 25 at the back. We just need to rewrite it because that is, we didn't substitute that for now. Okay. So this is what you get when you substitute, but we have to do some simplifications here. So what can you do here is we can factor. Can someone tell me what can we factor out here?
25.
25, and what you get when you factor 25 out, Escada?
5.
No, I mean in the here.
Oh, tan squared.
Tangent square theta plus what?
25.
No, you take 25 out.
1.
1. So be careful with this. Make sure you guys know how to factor. This is very basic factoring. Brush it up, because if you doesn't know how to factor this, please brush it up. Can someone tell me what is this tangent square plus 1 is? Do we have an identity for this fellow? We have, right? Which is called the what? The Pythagorean identity. So you notice already, since we are in here, do we use Pythagorean identity the most here? My answer is yes. So mostly in your test, if you guys are mini mo it, I will tell you that Pythagorean identity will be the one. And again, because of the square, that's the first thing. And we got right here, this is a Pythagorean identity we're using. So 1 plus tangent square is what? Actually is secant square, right? So 1 plus tangent square is actually secant square. So this will be replaced by secant square. So the 25 is still there. So the tangent theta plus 1 will become secant theta. So I just, instead of x, I use theta. Sorry, secant square theta. And since they are all perfect square, so we can write your final answer. So 25 is a perfect square of 5. And secant square theta, the perfect square is secant theta. So this will be your answer in this case. And we do not need to worry about putting absolute value or something else here, because as you know that in quadrant 1, all the trigonometric function is positive. Okay. So this is how we do question number 13 using substitution, trigonometric substitution, they call it. You probably won't, I probably won't come up with this kind of questions in your test, but you will see this in your online homework. Okay. And the last question that we are doing for this 7.1 here is number 14. You have to write this as a single log. So this is where you learn your college algebra, where you have your special, how we simplify log function. So if you remember it, good. If you don't remember it, I'm going to explain to you again what that is. Okay. So when you do this, is all the log. So if you multiply 2 logs, this is the same as adding. So this is what you guys did in college algebra. And if you do a division, we subtract. So you got log A subtract log B. So this is what you guys learn in your college algebra. And when you have a power, does anyone remember what happens when you have a power? What you're going to do with this power? Come on, you guys. Anyone know what's a power? What you do with him? You bring. Yeah, let's go.
That division?
No,
Like,
you bring the power to the front, so you will get m log a. So this is the power property. You bring it to the front. Okay. So if you look at question number 14, and don't forget, when I say equal, it's not just go left to right. It can also go well, right to left. So it's not, always one. So which one of these should we use for him? Number 1, number 2, or number 3? Which one is for this one? Since we have a positive here, so which one you think? One, two, three.
one?
1, because it's a plus, right? And what you do with the plus, you have to what? You have to
Multiply.
multiply. So you have to multiply this. So you take cotangent t, multiply with 1 plus tangent t. So you need to take these 2 and multiply it. I forgot the square. Now we need to put an absolute value on this fellow. The reason why we need an absolute value is because when you do log function, anything that is inside here, it has to be positive. A in this case has to be greater than 0. That means that your log cannot be negative and your log cannot be 0. So if you have a calculator, you just type log 0 or log negative, any number you want, you will get error. So that's why we need to put an absolute value here to keep him having a positive number. So we do not want it to be a negative number. So this is for you if you go to calculus class, make sure you have an absolute value on it. So my question is, if you look at this 1 plus tangent squared, we can apply identity on it. And I think you guys know what kind of identity we're using. Yes, we are still using the Pythagorean identity. So if you look at the 1 plus tangent t, it's just an x of theta. So which one is 1 plus tangent t here? 1, 2, or 3? Anyone? This is easy. We've been using this a lot. So 1 plus tangent t is what? 1 plus tangent square t is secant square t, right? Now, what we need to do here is we can further reduce this fellow. So, so everything is still ln here, and everything still have an absolute value. This is all going to be the same throughout the whole time. So what can we apply with cotangent t? Now we cannot use Pythagorean anymore because there's no square here. So which one here is the best for Pythagorean for cotangent t? We're gonna use the quotient here. So for quotient identity, the cotangent t in this case will be cos over sine. And the secant square t, we will use another identity for this because we can cancel some stuff. We do not want to use Pythagorean because when you use Pythagorean, you go back, you're going back previous one, and we do not want to go back. So, so we will use the reciprocal identity in this case. So can someone tell me what is secant square t? Is 1 over cosine square t. And what do you notice here is the cosine and the cosine can be canceled out, and you still get 1 the cosine t in the denominator. So you still get 1 here. So you will get 1 over sine t and 1 over cosine t. And we will use back reciprocal identity in this case. So what is the 1 over sine in this case? 1 over sine is actually cosecant. So this will give me cosecant t. And 1 over cosine will give us secant t. So your answer in this case will be ln of cosecant t and secant t in absolute value. So this is your answer for question number 14. Yes, if you're going to calculus 1, this is what you'll be learning. This is something that you need to know. So so if this is your last math class, then you don't need to worry about it. And yes, we are not coming up this question in your test. So when you go to calculus, make sure you learn this. So this is how we do the last question on to write this as a single log. So 1 log here. So I'm gonna take attendance now. So put attendance. So please go and type present there. So we're gonna continue with 7.2. So this 7.1 is due on next Wednesday. Okay, don't forget. So 7.1 homework is due on next Wednesday. So I will start with 7.2 now. So what is the difference between 7.1 and 7.2 is 7.1, we want you to give me what is the answer here. Like this is 1 over cosine x minus 2 or plus 2. So in question in 7.2, we will be calling you to prove the identity. So that means you prove from one's left side to the right side. That means that, remember last time when we did 7.1, you got multiple answers. But in 7.2, I will tell you what answer we stop at. So there are few little guidelines I can teach you. So this is something that you need to practice. And this is very important. Who was that? So what is going on in this case, that the guidelines I can tell you is that you have to tell me, the first guideline is what side of the equation you start to work. And usually we pick on the more complicated side in this case, means the so in your test or in your test, you have to tell me, do you start from the left hand side or the right hand side? So the first thing you need to tell me is, do you start from LHS or the RHS? This is very similar to your geometry class in your high school that you prove your geometry. Very similar, but this time we use geometry. So that's the first step. You have to tell me what side you start from. Okay, so left hand side means left side of the equation. Right hand side is the right hand side of the equation. That's the first step. Second step, this is the guidelines. Okay, this is the guidelines. It means it's not always the same. It's not always true. If you can factor, you factor it. Okay, so anything that is factorable, make sure you factor it. The reason why we factor it is because we can apply identities, usually the Pythagorean one. If you have fraction, make sure you add your fraction or subtract your fractions. If you do that, make sure you find your LCD. Okay, like what we did in number 6 or 7 that we did here. Number 7, when we add and subtract, we do the LCD. If you see anything with square, you FOIL it out. This is at number 6 we did. Remember the first question we did? So every time when you see a square, a binomial, make sure you square it out. And the last one that we talk about in this case is this is number 2. And if you have we want to create what we call as a monomial denominator. Now, what is the meaning when I say a monomial denominator? A monomial denominator means that your denominator only consists of one term. So for example, it's like, make it easier, like x here. Okay, so we try to make this as a monomial denominator. The reason why you make it as a monomial denominator is because you can split this into 2. It'll become like this. Okay, so you can do this only if this is a monomial denominator. If this is a binomial denominator, that means or trinomial, you cannot do it. So if this is like let's say is x plus 1, you cannot split this into two. You can, it's gonna be very difficult to do, okay? So you cannot do like this. I mean, you can do it, but it's just very tedious. So if you have a binomial here, so what is the best way to do is you factor it. So back to the factoring. Okay, so in this case, you will get x squared minus 1 over by x plus 1 and oh, so this is the factor will be x plus 1 and x minus 1. So you can factor it and then you can cancel it. So this is what you do. So if you have a binomial denominator or trinomial or multinomial, you can only done what you can do is just factoring it. So this is what is number 2 is telling us. So this is just again a guideline for you guys. Use identities. The next guideline is telling us to use identity. Note that we use note that which functions are you in the final expression. So what do I mean by this? This is very important. A lot of students this is kind of a note that I want to point out. Look at what you want on the other side. So if you start from the left hand side, you want to see what is on the right hand side. If your right hand side is in terms of cosine, then try your best to use identities that goes to cosine. So sine and cosine pairs up, secant and tangent will pairs very well, cosecant and cotangent pairs up very well. The reason why all these pair very well is because of Pythagorean identity. So this is all reason that this all pair up is because of PR. Okay, just want to tell you that. So make sure you guys know what is your final destination, what you want. So you have to kind of think about outside the box. This is the last resort. So last resort means that that means you doesn't know what to do. So the last thing that I will suggest you to do is convert all the terms into sine and cosine. Okay, so you can change all your terms into sine and cosine. If you look at all your identities, yes, you can change all your terms to sine and cosine. You can change your tangent and cotangent to sine and cosine. You can change your cosecant and secant into sine and cosine, just one over it. So that will be something that I will want, that will be your last resort. Okay, means that don't do this. The reason why I don't want you guys to do this is because your work will be triple more longer than if you do it factoring or doing a foiling and all these things. So if you want to do everything in sine and cosine, your work will be a bit more longer work to do. It's not, and then you might be you might have a little block, like a root block in the middle there. So you got and the last thing that you're also thinking about is to multiply by the well-chosen one. When I say multiply by the well-chosen one, means you multiply by conjugate. So this is also another way, and we did that on 7.1. Remember the conjugate that we talked about on question 12 here. So this is only happens when you have a fraction, and you want to change it to be a not fraction. So this is only done when you have a fraction and your question has a fraction and you want to make it as a not fraction. Again, this is very last resort. That means don't do this. If you do this, just be careful because it might give you a roadblock when you do this. There is some big notes here. So these notes are very, very important. So please pay attention now because I'm not going to repeat again. So in your test, if you do this, you get a big 0 here. So when this is a big note that I'm talking about in here, is when we prove identity, proving identity is not the same as solving equation. So what do I mean by that is that you don't, when I want you to prove identity, you don't do like what you did solve equation, like if you add sine x over here, you add sine x over here, right? Or if you multiply by sine x over here, you multiply, like balancing the equation. You don't do this. For example, like question number, let me see, question number, like this one, question number 4 here. You don't, I don't like fractions. So won't David say that if you multiply this on that side, your fraction is gone, right? So a lot of students do that in my test is they do this and then they multiply, I don't like fractions. So I just do this, multiply this. And then what you do is you just prove this identity. It is, you can, yeah, this is correct. But what you get, a big fat zero test. So don't do that. This is what we call as solving equations, mean you try to solve it. And same thing happens like number 2, you don't move the, oh, I don't like the negative one. I'm going to move the negative one over there. Oh, I don't like this. I move. So you try to move this this proving identity. I will give you 0 in this case, no matter how you do it. However, if you want to move your basic identity that I give you here, all this, yes, you can move whatever you want here. This is fine because this is your identity that the fundamental identity is not the one that you need to prove. But once I want you to prove is fixed, that means you have to prove this side is the left hand side is equal to the right hand side. So this is something I want to tell everyone here in this class. So once you did something like what I just told you, like you try to solve this, or you try to add or subtract or multiply this, you will get a 0 in my test. I know it's graded, I just give you 0. Okay, so make sure you guys understand this. This is very, very important. Okay, this is very, so do not add or subtract and do not cross multiply and all these things, because we are not solving an equation here. We are proving identities. Questions you guys have here with all this little stuff that I'm telling you here. Very important stuff, especially the solving one, because I have students doing that in my test and they get a 0. And they will ask me what happens, and I will tell them that you cannot do that. Okay, so let's do some proving identity. So verify means prove the identity. They are the same thing. So cotangent square y secant square y minus 1 is equals to 1. So my question to you is this what you need to do in my test? Which side do you start from? The left-hand side or the right-hand side? And we always pick the complicated side to start with. So anyone know where to start with? Left or right? Which one is complicated, the left side or the right side?
The left.
So we start from the left-hand side. So in your test, make sure you put down LHS. Means you're telling us we're starting from this side. So can someone tell me which one can be applied identity? And you can tell what kind of identity I'm talking about. So which one you want to apply identity here?
Secant squared y minus 1.
So, yep. So this will be Pythagorean identity. So anyone know what is secant square y minus 1 is? And unfortunately, you cannot change your y to become x or theta or whatever. You have to use y. So the cotangent, do we need to change this using Pythagorean? The answer is no. So usually the Pythagorean usually change 1, don't change both of them. So this is still cotangent, you don't change it, but you will change this using Pythagorean. Can someone tell me what is secant square y minus 1? Which one we do? 1, 2, or 3? Which is number 2, right? So what is secant square y minus 1? So we have to move the 1 over here. So what is happening when you do secant square y minus 1? What you get?
Tangent squared y.
Mm-hmm. Now we need to multiply this. So what identity do you need to do? Because don't forget, we need to get 1, right? So can someone tell me what identity we need to do to change it to become 1? Are we still going to use Pythagorean identity here? No, because we use it once. So which identity is the best to use so that they can cancel? So when you say 1 means they can cancel. So anyone know what identity to use?
Would it be quotient?
We can use quotient, or we can use what? Reciprocal identity. Quotient, you have to change both of this. Reciprocal, you just need to change 1. So I'm going to use a reciprocal identity. You can use you can use quotient, but then you have to change cotangent to become cosine, and tangent is sine cos. And then when you multiply, they all cancel out, become 1. But if you want to use a reciprocal, we can pick 1, don't pick 2. We can change this using the reciprocal identity. Can someone tell me what is tangent square y if you change it to become reciprocal, using reciprocal identity? This is 1 over cotangent square y, because tangent is 1 over cotangent. And what you do now is they can cancel. So what you got when you cancel? You end up with 1, which is the same as your right hand side, which is this side. Okay. So this is how you prove an identity in my test. Just want to point out to you guys that. So make sure you guys know how to do this. And usually you start from left and you end up with the right, and you have to use identities to do it. And again, that is not one way to do it. There is multiple ways to do it. And as someone mentioned, you can change it using quotient. You're still going to get 1 in this case. Okay. We'll do the last one here. Cosine square beta minus sine square beta is equals to 2 cosine square beta minus 1. So first, you need to tell me what sides do you need to start working here? The left side or the right side? You see a lot of square going on, so you kind of know what identity to use.
The left.
So you start from the left, very good. Okay, and again, you can start from the right, so left hand side. So this is a side you need to start. So since they all have squares involved, so what identity should we use?
Pythagoras.
So we use a Pythagorean identity. So I'm going to go up to the Pythagorean identity that we use. So so my question to you is, can we apply, as you know, this is all sine and cosine, right? So we definitely use the first one, sine squared plus cosine squared equals to 1, right? So this is the Pythagorean identity that we have here, sine squared plus cosine squared equals to 1. So famous one. Now a lot of students think about, oh, if sine squared plus cosine squared equals to 1, but this is cosine squared minus sine squared. Can you move this around so you will end up with this equation, this side? The answer is no, because if you want to change, okay, I'll move my cosine here, but what happens when I move my cosine here? That becomes negative. My cosine is positive. Oh, I want to multiply everything with negative, but when you multiply everything by negative, you got this negative sine square, which is here, but you also got a negative cosine square, which is not working. So actually, this fellow, you cannot move things around. Remember, I told you to move things around, move the 1 over and stuff like that. Unfortunately, you cannot do that in this case. So what we do here is we have to use substitution. Okay. So what you need to look at is your right-hand side. If you look at your right-hand side, are they in terms of sine or are they in terms of cosine? These are all in terms of cosine. So what you need to do here is this cosine is good because it's already cosine. So we just need to substitute this in terms of cosine. So how do we substitute? Is we use the Pythagorean identity and you solve for sine square. So sine square in this case, if you move it, it will become 1 minus cosine square. So what do I do is I take this fellow and I substitute this over here. So I still gonna have, oops, sorry. I still gonna have the cosine square beta here because I want to keep this. The reason why we are keeping this is because your right hand side has the cosine square beta. It's all in cosine square. So that means when you guys want to prove this identity, make sure what you have on the other side so you know what to plan on it. Now, now we're gonna substitute this fellow in here. So it'll be 1 minus cosine square beta, because it was a sine square. So we substitute. But because of the minus sign, this is also one of the mistakes a lot of students make. You need to give them a parenthesis. In other words, this negative will affect both the 1 and the negative cosine square beta. So you have to distribute here. So when you distribute here, you will get cosine square beta minus 1 plus cosine square beta. So the negative will make him positive. So if you look at this, there are 2 cosine, there are 2 of them. There's 1 here and 1 here. So you will end up with 2 cosine square beta minus 1. And this is the same as your right hand side, which is this one. So this is how you prove this kind of questions. So sometimes Pythagorean identity is not just like what we did in chapter 7.1, where you move things around, it works. When you prove something else, sometimes you require to use substitution. And which one you need to substitute, it depends on what you have. If this is in cosine, we substitute the sine. If this is a sine, we will substitute the cosine. So make sure you guys know which one to pick. If you pick the wrong one, you will get everything in the sine in the wrong form that what you have on the right side. So then you have to change it back. I should not pick the cosine, I should pick the sine in this case. So this is something that you need to practice. So a lot of students who do not do well in my tests because they are not in practice good enough here. So I do have homework for you guys to do besides 7.1. I want you guys to go home and try to do 3 and 4. So question 3 and question 4. I really want you guys to, so this is your extra homework here. So when you come back on Monday in my Zoom class, I will ask you how to do 3 and 4. And guess what? My notes is in D12, so you can actually take a look what is going on here. So so please, this is your extra homework here. So your homework in this case is only 7.1 on that is due on Wednesday. 7.2 and 7.3, I will recommend you to, especially 7.2, to start working on it because there's 2 homework here. So and also I will recommend you to also do 3 and 4 here. So please, I want you guys to practice this, especially for your tests. Okay, this is something that you need to do on your own, and I cannot really help you with. And a lot of students struggle with this kind of proving identity. Okay, so I'm gonna stop sharing here, and I'm gonna stop recording.